Hi everyone. Today we're going to study the second derivative test. Suppose f prime of x equals 0 and f double prime, or the second derivative, is continuous over an interval containing the point C. If the second derivative is greater than 0, or we say positive, then the function f has a local minimum at the point C. If the second derivative is less than 0, or we say negative, then the function f has a local maximum at the point C. If the second derivative of x is equal to 0, then the test is inconclusive. Let us see this example. Use the second derivative to find the location of all local extrema for the function f of x equals x raised to 5 minus 5x cubed. For our solution, the step 1 is to find critical points when f prime of x equals 0. This is our function here, so the first derivative will be 5x raised to 4 minus 15x squared. Let us set the first derivative into 0, so the left-hand side will be 0 equals 5x raised to 4 minus 15x squared. Now let us solve for x. Let us factor out the greatest common factor to each of the terms. So we have 0 equals the 5x squared times the quantity x squared minus 3. Now let us equate each factor to 0. So we have the 5x squared equals 0, and this x squared minus 3 equals 0. Solving for x in the first equation, we have x equals 0. On the second equation, we can transpose this negative 3 to the right, and then let us take the square root of both sides, and the value of x is equal to plus or minus the square root of 3. We have now these critical points, and we say that the critical points are the values when x equals 0, square root of 3, and negative square root of 3. Step 2. Find the second derivative of the function and evaluate it using critical points of step 1. A while ago, we solved for the first derivative. Now the second derivative is equal to 20x cubed minus 30x. We can simplify this expression into 10x times the quantity 2x squared minus 3. Now let us evaluate each of the critical points into the second derivative. Let's begin with the f double prime of 0. This is now equal to 10 times 0 times the quantity 2 times 0 squared minus 3. The 0 here outside makes the whole equation into 0. So the f double prime of 0 is equal to 0. Next, let us evaluate the f double prime of the square root of 3. This is equal to, we can simplify the radical and the power 2. So the number 3 here comes out as positive 3 to be multiplied to 2. So we have 6 minus 3. The difference will be 3, and that 3 will be multiplied to 10. So the f double prime of square root of 3 is equal to 30 square root of 3. Next, let us evaluate the f double prime of this negative square root of 3. This is now equal to 10 times negative square root of 3 times the quantity 2 times the square of negative square root of 3, then minus 3. We can simplify the expression here by cancelling the radical and the power 2. But take note, the negative sign here becomes positive. So when we cancel it out, the number 3 here comes out as positive 3 to be multiplied to the number 2. So we have 6 minus 3. And the difference is 3, and that 3 is to be multiplied with a 10. And everything now is simplified into negative 30 square root of 3. For step 3, let us now use the second derivative test. We say that if the second derivative is greater than 0 or positive, then the function f has a local minimum at the point C. Second, if the second derivative is less than 0 or negative, then f has a local maximum at the point C. But if the second derivative of the function equals 0, then the test is inconclusive, meaning there is no conclusion. Let us see now this f double prime of 0, and this is equal to 0. In this case, we say that it is inconclusive when x is equal to 0. Next is the second derivative of square root of 3, and the answer is positive 30 square root of 3. Since this is positive, we say that there is local minimum when x is equal to square root of 3. For the third critical point, and we have here the f double prime of negative square root of 3, and we found out that the answer is negative 30 square root of 3. Since this is negative, we say that there is local maximum when x equals negative square root of 3. Using the graphing facility, this is the graph of our f of x is equal to x power 5 minus 5x power 3. Let us examine the graph on its critical points when x equals negative square root of 3, when x is equal to 0, and when x is equal to square root of 3. We say that there is local maximum when x is equal to negative square root of 3, and it's here. Also, there is local minimum when x is equal to square root of 3. This is the point. And then, there is no local extremum when x is equal to 0. This is the point. This is now our final answer. I hope you learned something from this video. See you again next time.